This is section 6.5. We're going to divide polynomials. And there's two ways to divide polynomials. The first way is long division. So you're going to have to take yourself back to elementary school when you learn how to do long division. And if you don't remember this, watch the video and it might strike some memory about how to do this. So what we're going to do is we're going to say this polynomial x squared plus x minus 17 is being divided by x minus 4. So we're going to put the x squared plus x minus 17 underneath the division sign, or in the dividend, and then x minus 4. Okay, so now what we need to do is basically look at this value right here. So we have to ask ourselves, what times x will give us x squared? And the only thing that works is an x. So I'm going to put it up there on top of this one because the exponent is a 1 and so is that. So I'm going to line them up. So now what we do is you say, okay, x times x is x squared. But you have to do it to this one too. That's where this negative 4 comes in. So x times negative 4 is negative 4x. And subtract. Just like we would in a regular division problem. So when we subtract these two, x squared minus x squared, they cancel out. Right here is a 1. So we have 1 minus a negative 4, which is really 1 plus 4. So that'll give us a 5x. And now we drop down the next thing, which is negative 17. Okay, so now we have to ask ourselves, what times x will give us 5x? And that answer is 5. So plus 5. And now we go back again. 5 times x is 5x. And 5 times negative 4 is negative 20. And we subtract. These two are done. We have negative 17 minus a negative 20, which is really negative 17 plus 20. And that's going to give us a positive 3. Okay, now because there is nothing left over here to pull down, we're going to treat this 3 as a remainder. So we're going to put plus 3 is our remainder, and you put it back over all of this, so x minus 4. So this x plus 5 plus that remainder is your answer when you do long division. Here's another problem that we're going to do together. And so this long polynomial here is being divided by this trinomial. So we're going to put everything underneath. But there's one thing I want you to change about this problem, and it's kind of why I chose it to do together. Do you notice how we go from the exponent 4, 3, and then 1? We're skipping the squared, so we need to fill that void in by just, because there is no x squared, we'll just write 0x squared. Okay, so now I'll continue with the 4 and then minus 6. The reason we do that is because when we do long division, we might have an x squared, and there's not going to have anything subtracted with itself if we don't fill in this gap. And when you're doing your homework, when you get to something and they're not like terms, such as x to the third plus x squared, you know you can't add them up, so you have to go back to the original and make sure you have descending order of your exponents, which we do here. And then outside we have x squared minus 3x plus 5. And we're going to do the same thing. We're only going to look at this x squared. So we ask ourselves, what times x squared will give us 3x to the 4th if we multiply? and that is going to be 3x squared. So I'm going to line it up over here, and I'm going to multiply. 3x squared times x squared is 3x to the 4th. Multiply by this one now, which would be negative 9 x to the 3rd. And we have one last one to do it by, which would be positive 15x squared. And then we subtract. These go away. We have negative 5 plus 9, which is 4x to the 3rd. And we have 0 minus 15, which is negative 15x squared. And the last thing we do is bring down the positive 4x. So now we go through again. What times, this is what we're looking at here, what times x squared will give me 4x to the 3rd? And that would be 4x. So that goes there. And now we multiply. 4x times x squared is 4x to the 3rd. 4x times negative 3x is negative 12x squared. And then 4x times 5 is positive 20x. Subtract. Those are gone. Negative 15 plus 12 is negative 3x squared. 4 minus 20 is negative 16x. And then we bring it down. Okay? We're not done yet because we still have this spot right here to fill. So we have one more time through. So now we look at this first value here and we ask ourselves, x squared times what will give us negative 3x squared? And that is negative 3. And we go through. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x is positive 9x. And negative 3 times 5 is negative 15. Subtract. Negative 3 plus 3 cancels. Negative 16 minus 9 more is negative 25x. Negative 6 plus 15 is positive 9. Because there is no other value here, it's done, this is our remainder. So we're going to write the plus sign and put negative 25x plus 9 all over this. So x squared minus 3x plus 5. And this is your answer. This is a more complicated one, but as long as you do the same steps over and over until you reach the end, you really shouldn't have a problem with this. I'm going to go ahead and give you one to do on your own to see if you can do this by yourself. So go ahead and pause the video, and when you're done, I'm going to show the answer and you can check your work. And if for some reason you did something wrong, bring it to class and I can show you what you did wrong. So here's the answer that you should have gotten for this. And again, if you did it right, good job. If you didn't, then bring it to class and I can show you what you did wrong. And this is with long division. There is another way to do division, but this can only be done when you're given when you're dividing by a binomial. And it's called synthetic division. It's pretty simple. So what we're going to do is we're going to put this kind of like a half of a rectangle on there. And whatever this value is right here, you're going to do the opposite. So we're going to put a -3 out here instead of +3. And we're going to take the coefficients, which are these numbers. This one would be a 1, -8, and +5. We're going to line these all up and make sure that there are no voids or gaps to fill in. This one goes from 3, 2, 1, none. So we don't have to fill anything in there. So I'm going to write 2, 1, -8, and 5. Okay, again, that was just the leading coefficients of this polynomial. Now you're going to bring down the first one. Okay? And now we're going to look at this and we're going to say 2 times -3, that's -6. And you're going to add these together. Okay? So now we add them up. 1 minus 6, well, that's a -5. Okay, now you're going to do the same thing. Multiply, +15. Add them up. -8 plus 15 is 7. Okay, and last, multiply again. 7 times -3 is -21. Add these together. 5 minus 21 is -16. Now what you have here are the coefficients of the polynomial that is the answer. And the only thing you need to recognize is that if you start with a x to the third, you're going to do 1 less than that. So you're going to fill in x squared to begin with. Then it goes to x plus 7. And then -16 is your remainder. So we're going to put that over. And you just found all of this without having to do the long division process. Let's try another one. Okay, so we're going to take the opposite of 4, so -4. We're going to make that odd-looking rectangle, half of it. And then we're going to look at the coefficients here. We have a 1, a 4, a -1, and a -1. And the exponents do go down 3, 2, 1, none in order. They're not skipping anything, so we don't have to fill the gaps in. And we're going to bring down the first one. Then we're going to multiply -4 times 1, and that's -4. And then we're going to add them up, so 0. Then we're going to multiply, 0. Add these up. Multiply. Add them up. So now we have the coefficients for the next, for our answer. And if we look at the exponent that this one starts with, we go 1 less than that. So x squared plus 0x minus 1 plus 3, which is our remainder. Do you have to write this 0x? Absolutely not. You can just write the x squared minus 1 plus a 3 over x plus 4. And that would be your answer. All right, can you use synthetic division on this problem? We have a polynomial divided by a trinomial. Your answer should be no, and the reason why is because you can only use synthetic division on a binomial. So this right here is a trinomial. You can only have a binomial, and that's definitely not one. Okay, here's another one, and we're going to do the opposite of what we see. So we have -2. We're going to change that to +2 and draw our half rectangle. Now we're going to take the coefficients of the polynomial here. This is a 1. But do you notice how we have an exponent of 3 and then it jumps to 1? We have to fill in the gaps. So we don't have any x squared. So I'm going to put a 0. Then we can put the -3 and then the 4. And now you're ready to go with the problem. So go down, multiply, which is 2, and add. Multiply and add. Multiply and add. Okay, so now we're all set. We look at the exponent, which is a 3. We do 1 less than that, so x squared goes here. This is a positive. X, positive. This is our remainder over x minus 2. Personally, I think this is a lot easier to do than doing long division. But again, remember you can only use it when you have a binomial. Here are some things in your book that they explain it in the book, but I felt like we should do some problems together. So given polynomial f of x, which is just this right here, and a factor of f of x, which is this right here, factor out f of x completely. And so what we're going to do is we're going to do somewhat the same thing. So we're going to take the opposite of our negative 6 here and put a 6. Now we write down the coefficients. We have 1, negative 10, 19, and 30. And we're going to go through and we're going to do this. So bring down the 1, multiply. 6 times 1 is 6. Add them up. Multiply again. Negative 4 times 6. Add these up. Negative 24 plus 19, negative 5. Multiply by 6. Add these up. For these problems only, you should get a 0 for a remainder. And if you did not, then you did something wrong. So if you get a 0 here, we're doing everything correct. Okay, now what you're going to do is you're going to look at the 3, and you're going to go one step lower. So x squared minus 4x minus 5. Okay, so what we're doing here is we're factoring this polynomial. They give you one of them. So all you're going to do is go like this. Now the next one, we need to factor this x squared minus 4x minus 5. So you, again, go back to chapter 1 where we factored trinomials. We look at factors of negative 5. And we pick which one will add up to negative 4, which is definitely this one. So then over here we write x plus 1, x minus 5. All right, and again it says given polynomial function f of x and a 0 of f of x, find the other zeros. So again we're going to do the same thing. They actually give you one of these, but they don't have it set up. They just tell you what this number out here is. And remember, we took the opposite, so really, this would be x plus 3 as one of the factors, because it has to be the opposite. Okay, so let's go through and write down our coefficients. We have a 1 right here, negative 2, negative 21, and negative 18. Bring it down, multiply, add them up. Multiply, and then add them up. Multiply, add them up. Check to see if you got 0. You did, so we're good. Look at the coefficient. It's a 3, so we're going to start with a 2 and work our way down. Now that we have all of this, we want to factor it the rest of the way. Okay, so really this is what we're factoring. We need to find factors of negative 6. And figure out which one of these will add up to negative 5. this one right here will add up to -5. So we're going to write x plus 1 and x minus 6. And now we're going to set each one of these equal to 0. However, I could care less about this one because they already gave me the answer. So there's one of the zeros. X plus 1 equals 0. If you just take the opposite of 1, it's really -1. And the opposite of -6 is 6. And you can do the work for that to prove yourself right. These are the zeros.